So for my project, on the first half for the mini project, what I did was I went to Pokemon database and I pulled all the information from the website, which included mainly all of the stats and the names and the types of each of the Pokemon that were on of from all generations. And then I added five separate columns. So I split the original type column into type 1 and type 2 because it made it a lot easier to read things if I was wanting to do specific types. And then I added a weakness column and a resistance column to show the weaknesses and resistances. And then I added a generation column to be able to track things more. And so with that information, what I did was I made a script that whenever you would enter, the user was prompted to enter a an input of a name of a Pokemon they wanted all the stats for. And when they did that, it would spit out all the stats, the weaknesses, resistances, and its two types. But when trying to figure out what I wanted to do with the second part of my project, I was talking with a couple of other professional data analysts and people who work with data regularly. And one thing that kept coming up repeatedly with all our conversations was Power BI. So for my final project, what I did was I used Python and Power BI based off of the data that I had before because I had a full data sheet, a full like database of all the information of all the Pokemon that I made in a CSV file, and I wanted to see what more I could do with it. So I used Python code to create visuals within Power BI. So I wanted to some of the advantages of doing it are I'm able to choose like specifically what like data I want to look at and how I want it to look because some of the default settings of Power BI aren't that great, but there's a lot that I found that I could do with it. Another advantage, it also shortened the code a lot, and I had to, I had to refamiliarize myself with it and change how I was writing it because I don't need to read the CSV file or have to keep track of a different variable that then reads that CSV file and stores all the data frame there because it's already all stored here. Because I was able to make a whole thing based just off of this, and so I was just interested in seeing. Um, Mainly, I was interested in the stats across all the generations and all the types. I wanted to see if there was more power creep that was introduced through generations. But with this one here, I used Matplot Seaborn to be able to create this visual, which is only two lines of variables and data needed for all of it to get the result I wanted, which was to show the number of Pokemon per generation. And then I was able to, using this, I'm able to turn off the title to make it easier to view and read because the title will show up there. That's one thing I found out and was able to solve. Um, Probably the hardest thing with setting all of this up and doing all of it was just getting pandas, matplot, seaborn, and all those and different things to work within Power BI and Python because it was very difficult initially because it's not like Jupyter Notebook or Google Colab, which all have their own like it all has pandas and matplot and all those integrated within. So I had to figure out how to do that. But once I did, it became mainly just taking the code that I made before for the mini project and then changing it up in a couple ways. Like I said, removing the read CSV file and then changing different variables to work. The one annoying thing I found is you can't sorry, not Python. Power BI does not support user generated inputs, so I had to then create visuals of what I wanted for each of them. But looking at the stat totals that were average stat totals across each generation, I did find that there has been power creep through the generations. With Generation 2 being the weakest, which doesn't surprise me. A lot of those Pokemon are pretty bad. But what I was surprised with was Generation 7 being um one of the biggest spikes. It just shot right back up there. And then Generation 8 did not spike back up more after that. But that's a positive sign because Generation 7 had a lot of insanely strong Pokemon that were added, but I was able to see that has been power creep across each of the generations, and I then was interested in seeing, well, what types have the highest stat totals and seeing which ones are stronger with, you know, HP, all the different stats for it. I was not surprised to see that Dragon was the highest overall, highest total stats because that's what the majority of the legendaries are. I also was not surprised to see Bug being the lowest because those are typically the weakest, but I was a little bit surprised to see how drastic the difference was between first and second to last and last. But I was able to use more I guess complex lines, or more lines in general to get a result in this as well. Using these lines here, I was able to then split the two types. Well, not split the two types, read type 1 and type 2 in one to get the same results for it to be counted if they're counted as electric type. For example, an electric type Pokemon might have it be electric flying, but then be like grass electric. And so it would count the first one as an electric, but the second one as a grass type, when in reality it's one of both. And so using these, it was able to count both of them as one. And then I wanted to make colors that corresponded with each type to make the graphs look better. And then it's just a standard way of putting up together uh, a bar graph, and then using these here, I was able to put the exact value on top of the bar. So you're able to get that exact number without having to guesstimate based off of that. But yeah, that's really my project as a whole. Thank you.